Okay. Okay, students. So in last lecture we have discussed about the transport layer. First, we have discussed about the transport layer and its services. We have discussed about the port address. We have discussed about the process to process delivery, socket address. Then we have a basic introduction about that how this TCP protocol will work. We have in last lecture we have discussed about these sequence number, acknowledgement number, and all these pointers. Now in today's lecture our point is on the protocol with the name of UDP, that is your user datagram protocol. TCP stands for your transmission control protocol, right? Now in case of transmission control protocol, that is a connection oriented protocol. Connection oriented means what? In which first we will create the connection, then data is transferred, then we'll wait for the acknowledgement. This is how the TCP protocol works. But UDP, we can define UDP with a single word, that is best effort delivery. Best effort delivery of packet means what? In that case it will not wait for acknowledgement but it will assume that data generated by the source will by default reach its destination. That is the basic theory for the user datagram protocol. So I'll repeat. Normally you will face the question regarding the difference between the TCP and UDP. As we all know, transport layer works on the network layer and below the application layer, right? So TCP, transmission control protocol, that is used for the process to process delivery of packets, that will use the port address, that is the connection oriented. We have discussed about the 6 basic flags. We'll use the sync flag for the connection building and final flag for the connection termination. But when we'll discuss about the what will be the disadvantage with TCP? Obviously it will create some kind of overhead when you will again send the packets, acknowledgement, and this whole stuff will create the overhead. But although it will create control the flow, but it will create the overhead. So in case of UDP, we will discuss the user datagram protocol, that is the best effort delivery. We will use the UDP now. We don't need the acknowledgement. We don't use in the real time. Let's say we have the video recording. In video it consists of the huge number of packets, huge number of frame, 1 or 2 3 4 frame miss, that will hardly make any difference. Now user datagram protocol is a connectionless unreliable transport protocol. It does not add anything to the service of IP except to provide process to process communication instead of host to host communication. Now this is a very important line. It is connectionless. I hope you understand the term connectionless. Let's say we have source, we have destination. Source will flood the packets with the destination address. Which path it will follow, it hardly matters. Every packet is free to follow their own path as per the current requirement. Now unreliable means what? Like reliable source means what? That is confirmed source. Unreliable means what? That is not confirmed. Not confirmed means we are not bothering about the delivery of packet to the destination. Our only aim is to just send the packets. Whether it will reach the destination or not, that depends upon the network congestion itself. So it is unreliable. What we can say, it by default assume that whatever it has sent, it will reach the destination. So what it will do, it will not provide so much services of the transport layer. It will not provide the flow control. It is not connection related. What it will do, it is just process communication instead of host to host communication. That means we are going to use the port address. So the very simple protocol is there. Sorry, header is there. Header of 8 byte. If it is 8 byte, how many maximum bit it will support? 2 raised to power 8. So source port number and destination port number 16 bit each. Port number means your process number. We have already discussed in detail that what is the port number. So there's no need to repeat this. Now we have the two new terms, total length and checksum. How we can define the total length and define the total length. Total length means the length of header plus data. Length of header plus data. Now this is 16-bit. 16-bit means that means total length it will support 2 raised to power 16. 2 raised to power 16. So what will be the header length? 2 raised to power 16. That is your total length. Total length minus data is your header length. Now checksum. Checksum is a technique in which it is used to generate the redundant number of bits. That redundant number of bits are used to detect the error when the packet reaches at the destination. With the help of the checksum bits, it is going to check whether there is error in the packet or not. If it is error free, then it is accepted, otherwise it is rejected. Now UDP length. UDP means user datagram protocol length. That is the IP length minus IP header length. Let's say the pseudocode for the checksum calculation. Now how it will calculate that 30, so IP address, IP here, IP, we are talking about the transport layer. Don't forget, IP, internet protocol that works on the network layer. IP protocol works on the network layer, right? So it has the pseudocode, the already available or whatever it is, get 32-bit source IP, destination IP, protocol, which protocol it is going to use, 16-bit UDP total length. Now header of this transport layer UDP protocol, source, destination, UDP and checksum. Now how checksum will be performed, we have already discussed it. This is not so much task to bother about. Now the main thing, the consideration of this UDP is on the services it is going to provide. It is a short lecture, and here we have already discussed. You will normally face a question of difference between the UDP and TCP. Connectionless, no relation between the datagram, not number means we are not going to use the sequence number. No relation between the datagram. If there is no sequence number, that means it can follow any path. But how we can reassemble at the destination? Obviously we need some kind of identification. No flow and error control, no window mechanism. In case of TCP, we have the Windows protocols. Windows protocol are used for the flow control, so there is not any kind of method in that case. No error control except checksum. Checksum is only for the header. Remember, checksum is only for the header. Encapsulation and de-encapsulation. Here, what we can do, this pseudo holder will be encapsulated in the UDP packets, right? Now queuing, incoming and outgoing queue, that we have already discussed. It only obtain one port number, port unreachable ICMP message. ICMP means your internet control messaging protocol, that if port is unreachable, that means queue is full. So this is how it works. We have one incoming queue, we have one outgoing queue. Port number 52,000, port number 13. There's a communication between the client and server. So for one port we have two queues, one for packet it receives, one for packet that it used to generate. So this is how it works. The suitable, so where we will use the UDP if we have no connection, we have no reliable, so we are going to use that is suitable for process that require simple request response communication with little concern for flow error control. Where we have no concern for flow, we have no concern for error, that is best case for the UDP. Suitable for multicasting means we are going to send the same packet for the group of destination. For that case, we will use the UDP. Used for management process such as SNTP, right? Used for routing updation protocol, routing information protocol. Routing updation means when router configure itself, it will send hello packets or it will send its neighbor information to all the other present in the network. In that case, we will use the UDP protocol. So that is TCP protocol that we have already discussed in the last lecture. So this is the basic difference between the TCP and UDP. I hope you understand. Thank you.